going to explain lesson number 1 of Rstudio. So first of all, let's see what we have in Rstudio. Rstudio has 4 windows. This is the main window where you are going to work with it. As you can see, these are some comments which we have already prepared so that you can do the commands directly. You don't need to write. So anything written in greens, these are just comments for yourself. They doesn't run. The second window we have here, it's called environment window. Here, whatever data we name and save, it will be saved in the environment window. And the third window we have here, we have file plots. Mainly we are going to use the plots. So whatever plots you have, it will be displayed in this window. There is one window called console window. This window will show you the calculation results. Some students, what they do, instead of writing their codes in this window, they directly write the codes in the console window, which is not even wrong to write. Okay, so let's start first of all, learn how to use Rstudio as basic calculator or in calculation of basic math operation. For example, you want to add 2 plus 3, you write 2 plus 3, and then to get the outcome, as I said, the outcome will appear in the console window. So you have to click on run, or you can click on Control Shift Enter. Your cursor must be on the same line which you have written your code, and press Control Shift Enter so you get your answer. Okay, in case of subtraction, you want to subtract, you have to type 2 minus 5, for example, and click on run. We get our answer in the console window. If you want to divide, the symbol we use for divide is 8 divided by 4, for example. So we write 8/4, click on run, we get 2. Multiplication, we can do it by using the symbol star. So for example, 3 multiplied by 3, we will write 3*3. Click on run, we get the answer in the console window as 9. If, for example, we want to compute 2 power 3, we can use 2 shift 6, 3, and click on run, we get 8. Or you can use 2**3, and we will get the same answer. If, for example, you want to get the remainder part of dividing 8 over 3, we can write 8 percentage 3. This operation gives us the remainder of division of 8 over 3. If we are interested to get the integer part for the division of 8 over 3, we can write 8 percentage divide slash percentage 3. We will get the integer part when 8 is divided by 3. Now R also has some built-in function. So what are the built-in functions we have in R? If, for example, you want to compute e to the power of -2, e is an exponential function. The function which is used in Rstudio for exponential is exp. So the command we use is exp. And then whenever there is a command in Rstudio, you have to open a bracket, or automatically the bracket will be open once you click on the function. And then inside the exponential, we want the exponential of what? We want the exponential of -2. So we write -2, we click on run. So the answer is 0.13533353. Let's assume that we want to round our answer, because normally you will be asked to round your answer. So the function which we use for rounding is round. First of all, you need to write your copy your answer. For example, copy, Control C, click on the answer, Control C, and then paste it here, Control V, comma, to how many decimal places you want to round your answer. We want to round it to 3 decimal places, so we write 3. Click on Run. So we get our answer 0.135. What is the function used to get the sum of 2, 3, and 5? The function for summing is sum. And then click on the sum, or just open the bracket and write the numbers that you want the sum of these. So 2 and 3 and 5. So the sum of 2, 3, 5 is 10. Let's assume that we want to find the square root of 122. So the square root function in RStudio is sqrt. And then we want the square root of 122. We write 122. Let's assume that, so the answer appear 11.04536. If we want to round it, we'll write round. We take our number, the answer, Control C, we put it here, Control V, comma, to 2 decimal places. Let's assume that we want the sum of the first 9 number. So sum 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one way. Or you can write sum, because these numbers are in order, one from 1 to 9. It's like a sequence. So you can write 1 colon 9. So it will calculate the same way we have done for the previous one. So we get the same answer, 45. Okay, next. What is the average or the mean for the first 5 number? So here we want to calculate the average. The average, the command we use is mean. First 5 number means 1, 2, 3, 4, 5. Or you can use mean 1 column 5. So it gives you the sequence from 1 to 5. So both are correct. Click on Run. We will get. Okay, let's see what we have here. Ah, yes, there is one mistake here. That's why we are not getting the answer. Okay, we'll go back on this. The mean of yeah, it should be 3. Yes, correct. Okay, so the square root of 20, what will be the answer? SQRT of 20. Rounding the answer into 2 decimal places for the square root of 20, we can just take round and then take our answer up to 2 decimal places, so 2. Okay, if you want to save the answer of the square root of 20 in X, so what do we mean by that? our environment is empty. Normally, when we open a new R script, the environment will be empty because of whatever we have done here, all the operation which we have done here, we have not saved our answer in the environment. So let's save our first answer for the square root of 20 as x in the environment. So we will say x equal to sqrt of 20. So what will happen? Whenever we call x in any place of this document, then our x is known as the value of the square root of 20, which is 4.472136, because it's now saved in the environment. So when you say, for example, when you say x plus 2, it will assume that your x is known and it's already there in this program and it is stored in the environment. So x plus 2 means the value of the x will be used, which you have saved, and you add plus 2. So you get your answer. Now let's round our x into two decimal places. So round x 2. So which x they are going to take? The one which is served here in the environment. Okay, next is find the factorial of 6. The function we use for factorial is factorial. And then we write the value of the factorial we want, factorial of 6. Find the exponential of 6. So the exponential function, as I mentioned earlier, is exp, and then in the bracket we write the exponential of 6. Find the logarithmic of 20. So the logarithmic function is log, then we write 20. Okay, what about find the logarithmic of 20 with base 2? We'll write log 20, comma, we can write the base equal to 2. Find the absolute value of minus 14. So here we want the absolute value. The function used for absolute value is abs, minus 14. Find the integer before the number 4.6. So it's like you are rounding your number into the into the previous integer. So if you are rounding your number to the previous integer, the command we use is floor. Floor, for example, for 4.6. What will be the floor? It will be 4. If you want the floor for 3.2, what will be the floor? The integer which comes before 3.2 is 3. What is the floor for 9.8? The integer which is coming before 9.8 is 9. What if I want the integer which comes after this number? Then we use ceiling. Ceiling of what? For example, 4.6. We will get 5. So same thing for ceiling. Let's say for 9.8, what we will get? We're going to get 10. Okay. These are built-in functions in Rstudio. So we have covered all the built-in function. Now we move to the next topic, which is creating vectors in Rstudio. Let's assume I have a vector. Now our x is known as this value 4.472135. Let's rename. Let's replace the x as a vector. So let's assume we have a vector x If you want to create a vector, the command we use is C. So C means a vector, column vector. Inside the vector, what are the values we have? It contains the first 5 numbers. So you can write 1, 2, 3, 4, 5. So now your vector has your x value changed as num, means numeric, and it has a values of 1, 2, 3, 4, 5. So now our x replaced as a vector. Create a vector y which contain the first multiple of 5. Let's create another vector y equal to a multiple of 5. So let's start with 5, 10, 15, 20, 25. Okay, so again, when I click run, the vector y is saved in the environment with 5 value. And the value, if you just extend this, you will see the values also. To identify the type of the vector, we can see in the environment NUM. So the type will be numerical vector because it contains only numbers. But if you're asked to know what is the command you use to identify the type of the vector, then you say class and then write what you want. So you want the type of vector x or type of vector y. Class x means what is the type of vector x. So your answer appear as numeric. What is the class for y? Again, it should be numeric. Okay, so these are numerical vector because it contain only numbers. Now let's assume you have a vector m which contain a, b, c, d. So once you run the vector, you will see the vector appearing in the environment as with the name CHR. So what we mean by CHR? What is the type of this vector? 1 up to 4 means we have 4 value in the vector. But what is the type of this vector? So what we will write? Class, and then we write the name of the vector. We click run. So vector M is a character vector, or it's a categorical vector because it only contains text A, B, C, D. Now, what about the type of the vector N, which contain one letter and then some numbers? So what will be the type of that vector? Of course, if there is one letter, if there is one text, then that vector cannot be a numeric vector. So first of all, let's run and see what we will get. Class of N, vector N again will be a character vector because there is one character. Okay. What about if we have a vector Z which contain true and false? So what will be either the full word of true or T? T means also true. F means false. And again, we have T, which means true. So what is, first of all, let's run the vector Z. Then we will see what is the type of vector Z. So it's a logical vector because it contains logical statement. What about if we have one text, one logical element, and then 3 numeric numbers, 3 numeric values? So what will be the type of that vector? Let's run it. H is appearing as CHR, so it will be a character vector. So when we have logical and numeric and character, the power for the character is more. So that's why we will consider that vector as character. So this command class will identify to us the type of the vector we have. Now, if you're asked, find the length of the vector. So it means how many elements you have in x, y, m, n, h. You can know how many elements here. See, 1 to 5 means you have 5 elements in h, 4 element in m, 4 element in n, 5 element in x, and 5 in y, and 5 in z. But if you are asked to find the length of the vector using the code length, then you can use length and put your vector inside the length command. Let's run these and see what we will get. So we are getting the length of each vector. So these are things regarding the vector. Now let's move to the next part of our session, which is creating sequence. Let's assume that my sequence contain number 6 10 times. So I'm repeating number 6 10 times. So the function we use, the command we use for repeating is rep, and then what we want to repeat and how many times we want to repeat. You can write like this, or you can write like this also. 6 comma, and then you write times equal to 10. So it's up to you. How do you want to write? Okay, now it is asking me to store the answer as z. So our z now, it's a logical vector. Let's replace our z with a vector containing 6 10 times. So now z is replaced, renewed with a new numerical vector. Repeat your name 20 times and store it as my name in the environment. So my name is a vector which contain my name. So it's a text. I should put it in the apostrophe. And how many times I want to repeat it? 20 times. So I'm getting here a vector called my name, and it is repeated 20 times. If you just enlarge, you will see. Okay, what about if you want to create a sequence of number from 1 to 100? There are two ways to do that. You can write 1 colon 100. Okay, you will get 100 numbers from 1 to 100. Or you can use the command sequence, SEQ, sequence of number from what to what? From 1 up to 100. Okay, so same outcome you will get, numbers from 1 to 100. Let's assume that I want to store the sequence 1 to 100 as a name W in the environment. So I'll say W equal to sequence 1 to 100. Okay, so I'll not get my outcome here because I saved it here as W. So W is an integer from 1 to 100. Create a sequence with a name n which contain multiple of 5 to 500. So let's say, first of all, say n equal to sequence from what to what? From 5 to 500. Anything else required from us? No, just from 5 to 500. Okay, so n is a sequence from the first number we have in the n sequence is 5. The next will be 6, 7, up to the last number is 500. Okay, try the following sequence. Let's see the sequence. Sequence from 5 to 10, comma 1.5. So what this 1.5 represent? Let's run the sequence 5 to 10. So our sequence will start from 5 and up to 10. So we get 5, 6.5, 8.0, 9.5. So what we have done, our first number we have is 5. If we add 1.5, what we will get? 6.5. If we add again 1.5, what we will get? We will get 8. So the difference between the first and the second number is 1.5. Second number and the third number, the difference is 1.5. Third number and the next number is 9.5. We cannot add again 9.5 plus 1.5 because we get 11. And 11 is not in the range. We want the sequence of numbers starting from 5, ending up to 10, and the difference between the numbers in the sequence is 1.5. So these are our results. We will stop up to 9.5 because if we add again 1.5 in the 9.5, we will get a number which is more than 10. Okay, so this is regarding the sequence. Now let's move to the next part. How we subset a vector. Okay, so let's assume we have a vector which contain numbers and text. So what will be the type of this vector? Let's call it myvec. So myvec is stored here, myvec, and it has 8 values inside the vector myvec, and it is a character vector because we have some text inside the vector myvec. I want to extract the first 3 values of the vector myvec. So I'll write myvec. The symbol or the command we use to extract the vector, we use these brackets. These brackets subset our vector. So what I want to extract, I want to extract the first 3 values. The first 3. So I'll write the first value up to the third value I want to extract. Let's run. We are getting the first value, which is 10, 20, 55. Now extract the third value of the vector myvec, only the third value. So I'll write myvec. I put the subset symbol is the brackets, and I will just write 3. 3 means I'm extracting only the third value of the vector myvec, which is 55. Okay, so now extract the first, the third, and the eighth. So extracting myvec, and then I put the bracket. What elements I want to extract? The first, the third, and the eighth. So I'll write this number, but I have to put C because I'm having 3 different value and they are not like a sequence of number from 1 to 3. So the first one, the third one, the eighth value. So when I click on that, I will get the first value of the vector myvec, and then the third one, which is 55, and the eighth one. Okay, next, extract everything except the first value. So what we will do, we'll write myvec subset -1. So what does -1 will do? It will extract everything from the vector myvec, except it will exclude the first number you have in myvec. So it's extracting. So see here what you have. See here what you have in myvec. In myvec, you have extracted everything except the face value, which is 10, is not extracted. You have not taken as a subset. Extract everything except the first, third, and the eighth. So the same operation I did here, but I'll exclude. This time I'm going to exclude the first value, the third value, and the eighth value. Okay, so click on run. So I'm taking care, I'm taking all the elements except the first element I have removed, the third element I have removed. See, there is no 55 here, and the eighth element I have removed. Okay, so this is regarding the subsetting of the vector. Let's learn how to subset data frame. So first of all, let's learn what we mean by data frame. Data frame, if you have many vectors and you want to combine them as one data set, like as one table you have. So let's assume you have a vector program. Let's run this. And you have a vector which contains the level of the students, and you have a vector contain the GPA of the students. I want to run all these together as one data sets. So what is the command I use to create a data sets? A data sets, it's called data dot frame. And then inside the data dot frame, I write the vector which I want to combine. Program, comma, level, comma, GPA. Run them. So now you're getting your vector, these three vector together as one data sets. I didn't name it. That's why it's not appearing in the environment. So let's name it. Let's give it a name as applied. Applied equal to, and then let's copy this. So the name given to the dataset is applied. So now applied appear, and there is an arrow in the applied. If you click on the applied, see how, first of all, what we have. See, these are values because these are only vectors. Now applied is the data set. So that's why it's appearing separately as a data file name applied. We have 10 observations in the dataset, and we have 3 variables because we have 3 columns. If you click on applied, it will take you to another window like a table. It will show the program, the first vector, the second vector is level, the third vector is GPA. Now let's go back to our previous R script window. Okay, let's learn how we are going to subset the data frame. So to extract a column from the data frame applied, we use the $sign, because when you write applied and when you click $, it will show you, it will list you all the variables you have in applied. So let's assume that I want to extract level. So I click on level. Okay, so it will show me what you have in level. In the level we have the level of the students. Okay, so if I want to extract only program, applied, program. Okay, so next thing is how we are going to show the first 6 observation of the data frame applied. The command we use is head, and then applied. So what does the command head will do? It will show me the first 6 observation of the data sets applied. It's only show the first 6 observation, not because in applied we have 10 observation. The command head only shows the first 6. Okay. So if I want to show the last 6 observation, the opposite of the word head is tail. And then I write applied. Okay, I'll get the last 6 observations. So it will start from 5, 6, 7, 8, 9, 10. The last 6 observation. Let's assume I want to extract. So here I'm subsetting the data sets applied. Okay, so applied is not a vector, it's a data set. It's like a table which has row as observations and columns as variables. Okay, so extract the row 2 and column 3. So we should mention the row number and column number because it's not like extracting a column only. We're extracting row and column. So applied, we write applied. What we have used when we have extracted or subsetted the vector with the same symbol we use to subset the data sets. So the bracket we use is that one. And then we have to identify the row number, comma, the column number. It's only one row and one column. So row number is 2 we want to display and column number 3. So what do we get? We get 2.14. What is 2.14? Let's go to the applied data sets and see row 2, column 3. What do we have? Row 2, observation number 2, column number 3. The answer is 2.14. So the same answer we got here, 2.14. Now let's extract the first 4 rows from applied. So right, applied subset, the first 4 rows. So 1 up to 4 rows, but I did not mention the column. So I just keep it empty. After comma, I keep it empty. So I'm getting the first 4 rows, comma, I have not mentioned the column I want, so all the columns will appear. Now opposite, let's extract the first 4 columns. So what I'm going to write, applied, subset. I did not mention the row, so I'll keep it empty and I will write in the column part, I will write 1 to 4. So when you mention the column, you have to write after comma. When you mention the row, you have to write before the comma. So it will give me we don't have 4 columns. The first 3 columns or the first 2 columns, let's write. We don't have 4 columns. Okay, so we are getting the first 2 column. Extract row number 1, row number 2, no, row number 5, and extract column number 1 and 3. So in case we have something like this, we write applied subset. We have 3 different rows. So C 1, comma 2, comma 5. These are the row numbers, comma, and then I write C, the numbers 1 and 3. So these are for the row numbers and these are for the column numbers. So we will get the answers like this. Row number 1 to 5 and column number 1 and 3 only. Okay, so this is regarding the data frame. Now there is something called list. So let's see what is the difference between the data frame and the list. Let's create a list which contain these vectors and we name it as shop list. So shop list is equal to a list of some vector. First vector is having 3 elements, second vector having only 1 element, veg. Third vector is having 1 element, not. Fourth vector is having 50, 10, 5, numerical vector. And the third list having the data frame applied. So let's run it and see what will happen, where it will go. So it is saved as shop list here in the data, and it is showing that we have a list of 5. So if we click on it, it will show as the list. The list has 5 lists. Number 1, it has a vector, character vector, which has 3 elements. Number 2, we have a character vector with 1 element, character vector with 1 element, and then we have a numerical vector 5, 10, 5, and we have a data frame with 10 elements and 3 um, uh, columns, 10 rows and 3 columns. We can open that later on. Okay, so let's extract the element of the first vector. So if I want to extract the first list, see how the first list is written. The first list is written like this. So just write shop list bracket bracket number 1, you will get the first list. If you write shop list bracket bracket number 2, you will get the second list. So it's not same like data frame. If you want to extract the data frame from the list of shop list, you have to write shop list. Where is the data frame saved in the shop list? It is saved in the number 5. So you write shop list number 5, and you will get the data frame. Extract the fourth list. Okay, so let's write shop list bracket bracket 4, but only the second value in the number 4 list. So second value means you write shop list bracket bracket 4 and then bracket bracket 2. If you want to extract the first list, you write shop list bracket bracket 1, and what value you want to extract? The second value, so bracket bracket 2. Okay, so these are regarding the shop list extracting. So it's different than data frame. Let's move to the 9th part of our lesson 1. We have something called built-in data frame. Means these data sets are already there in Rstudio. The one we have taken in our class is called empty cars. It's a data frame already there in R. So let's write empty cars. So see, if you write empty cars, what do you get? If you run it, you will get the data set. So this data set is already there in R. Let's work with these data sets. So let's bring it inside the environment and call it as a name car. So empty cars equal to car, or car is equal to empty car. Empty cars. Okay. So now we have car is a data set which has 32 observation and 11 variables. If I click on it, I will get the data sets car. Now, how many columns are there? You know that we have 32 observation, 11 variables. So 11 variables means we have 11 observation. But if you're asked to find the number of columns using a command, the command we use is called ncall. And then we write car. We will get that we have 11 observation variables or 11 columns. If we want to know the number of rows, we will see how many observation we have. 32 observation means 32 rows we have. So the command you use for row is in row. And then you write your dataset name. Click on it, you get 32 rows. As I mentioned before, if I want to display the first sixth observation, the command we use is head. If I want to display the last six observation, I will use opposite of head is tail. If I want to extract the first row, I write car subset, because data set means as a table. No, we have it's like a table. So if I want to extract, I have to mention the row number and the column number. I did not mention anything about the column number, so I'll write 1, comma, I'll keep it empty, means all the column I want for row number 1. So I will get for row number 1 all the values, all for all columns. If I want to extract column number 1, then I write car subset. I keep empty in the row and I'll write comma 1. So these are the value for column 1. Column 1 means MPG. So first number is 21, 21. Yeah, we are getting that. If I want to extract column 3, I write car, keep empty in the row part and write 3. Okay, so I'm getting column 3, which started with 160. So let's see. Column 3 is 160, 160. That's correct. Extract row 2 and column 3. So car subset row number 2, column number 3. I'll get only one value, which is 160. Extract the first 20 observation. So observation means rows. So car subset first 20. So 1 up to 20, comma, column number I did not mention. So first 20 observation regardless of the column. Extract the first 5 variables. I did not mention the row, I said columns. So I'll write first 5 variable, 1 up to 5. So I'll get the outcome for the first 5 variables for all rows. Extract the column number 1 to 5. Okay, 1, 2, and 5. So they are not in order like 1, 2, 3, 4, 5. I said car, comma, I have to mention exactly which column I want. Column number 1, column number 2, and column number 5. So I'll only get the result for column number 1 in car, column number 2, and column number 5. Column number 1 is MPG, column number 2 is CYL, and column number 5 is DRAT. Okay, next is same thing. If I specify the row number, so I have to write exactly in the C the row number I have 3, 7, 9, and 10. And then nothing mentioned about the column. It means all the columns are included. If I am extracting row number 1, 10, 20, I have to write car bracket C. I'll put C because I have different numbers of rows. So 1, 10, 20, 28. And then I have different number for columns. It's not only one number, different numbers. So I'll use 1, 4, 5, 8. So I'll get these rows and columns. So I'm getting for row number 1, 10, 20, and 28. Column number 1, 4, 5, and 8. Okay, so these are the things that you have to learn from lesson 1. Thank you for listening. We'll go now to lesson 2.